Hi, this is Alex from devstories.eu. OpenCV Computer Vision Deep Dive, Episode 8 of 20. Before modern systems arrived, object detectors had to scan a single image dozens of times at different scales just to find a target. It was painfully slow and computationally heavy. Then a new architecture revolutionized the field by doing the entire job in one incredibly fast mathematical sweep. Today, we are looking at the YOLO lineage, fast object detection. To understand why you only look once, or YOLO, changed everything, look at the prior standard. Older multi-stage pipelines relied on regional proposals. They would generate hundreds of guesses about where an object might be, crop those areas, and then run an image classifier over every single isolated patch. You were running complex networks in a loop. It was disconnected, difficult to optimize, and fundamentally slow. Some developers confuse YOLO with standard image classification, which simply assigns a label to a full picture. YOLO does much more. It outputs precise spatial bounding boxes alongside class probabilities. It tells you what the object is and exactly where it sits in physical space. YOLO achieved this by reframing object detection entirely. Instead of a multi-stage pipeline, it turned detection into a single regression problem. The logic goes straight from raw image pixels to bounding box coordinates and class probabilities in one continuous step. Here is the key insight. YOLO takes the input image and divides it into a uniform grid. If the center of an object falls into a specific grid cell, that exact cell becomes responsible for detecting the object. Each grid cell simultaneously predicts a fixed number of bounding boxes. For each box, it outputs the center coordinates, the width, and the height. It also outputs a confidence score, which tells the system how certain it is that the box actually contains an object. Simultaneously, the cell predicts class probabilities. It is calculating whether the object is a car, a truck, or a person. The network then multiplies the box confidence by the class probability. This single mathematical operation filters out all the weak guesses across the entire grid, leaving only the highly accurate bounding boxes. Consider a high-speed highway toll camera. Cars are moving at 80 miles per hour. You need a single pass network to draw bounding boxes around license plates before the car leaves the frame. A multi-stage detector would lag, cropping and analyzing isolated patches of asphalt while the car speeds away. YOLO processes the entire frame at once. It applies the grid, predicts the geometry, and calculates the probabilities in a single forward pass of the neural network. Because YOLO processes the entire image in one sweep, it inherently understands the global context of the scene. Older models often mistook patches of background for objects because they only saw isolated crops. By framing detection as a single regression problem over a grid, YOLO forces the network to learn generalized representations of objects in their full context. Thanks for spending a few minutes with me. Until next time, take it easy.